Hello, everyone, and welcome back to CCIE Labs Uncensored with myself, James Haddix. In today's lab, we're going to go over everyone's favorite subject, which is spanning tree. Spanning tree is what I like to call the root of all problems, pun intended. In today's lab, we're going to do a simple configuration of changing the priority of switches in our basic lab configuration. So I'll go ahead and remind everybody what our lab configuration does look like. Again, we'll be working with these switches right here, 1, 2, 3, and 4. And in today's lab, this is what we're going to accomplish. We are going to configure all switch links from switch 1 as static .1Q trunks. Then we're going to create VLAN 2 across on all switches. Then we're going to set switch 4 as the root using lowest priority. And then we want to set switch 2. Actually, I'm sorry, we're going to set switch 1 as the backup root. So, what does the backup root mean? Well, obviously that means using the second lowest priority. Hopefully, as most of you know, spanning tree, if left to its devices, will elect root based upon the MAC address of the switch. Obviously, this can be fairly dangerous, because you might have a switch further down your topology that might have a MAC address that would allow it to be the root, which would considerably do damage on your network. So that is why spanning tree is very important to plan out. We're doing a very basic version of spanning tree. Obviously, you have rapid spanning tree, you have multiple spanning tree. But this is sort of a generic kind of get our hands wrapped around what spanning tree is at its root. Again, pun intended. So let's go ahead and bring up our switches. So looking at this lab right now, we could theoretically say, or we could actually create VLAN 2 using VTP. That would be fairly easy. We could just simply also just create it manually on all the switches, which we're just going to do because, again, we're just trying to get to the heart of what spanning tree really is about. So we'll go ahead and do our first task here, which is configure all the switch links. And we're going to do, and so before we can set static trunks, we have to enable the correct encapsulation. So that would be .1Q. And then we can just set it to a static trunk. So now we have all of our trunks set up. And I noticed here while I was working on this lab earlier, so I might have already created VLAN 2. I did on this switch. Let's check the other ones. So here, show VLAN. So I've already created VLAN 2. VLAN 2 is on switch 3, and switch 4 should also have VLAN 2. So show VLAN 2. Oh, sorry, so VLAN. And that is actually correct. So this. All right. So I did a reload on these switches when I did the lab, sort of a quick practice, and it kept the VLAN. Well, why is that? That is because when I did the reload, the VLANs that are created do not go into the configuration file. They actually go into the VLAN.dat file. That is the VLAN database. So when you do a reload, the VLANs still stay on the switch. So that is why those are still there. So a little quick reminder for everybody. So now that we've actually got these two done, let's go ahead and go to switch 4 as root using lowest priority. So I want to make sure that that part configuration actually wasn't saved. So let's do show spanning tree VLAN 2. And if you can tell right now that switch 4 is not the root, obviously. We could tell here because there is a root port associated with this, and then there's an alternate port. So obviously if this was a root port, then this would be the roles would be a lot different. The second part is also that it would actually state in this particular part in the root ID that it would say this root is this bridge is the root. And then again, going over something that pretty much everybody should know, that the priority is 32,768 plus the system identification, or plus the VLAN. So that actually gives the priority. So when VLAN 1, you'll always see 32,769. So, and right now this is showing that the bridge ID is this MAC address. So let's see which switch that is. Close that up here real quick. That's on gig 3 is the root. So I believe it should be switch 1. And it is showing 01 as the root, and that goes to switch 2. So let's go over to switch 2. And switch 2 is showing that is not the root either. So let's go to switch 3. So spanning tree. Ha, there we go. All right. So just forgot my topology there for a quick second, but this is how a switch will show as being the root of a VLAN. Now, because we're not running multiple spanning tree, there will be different instances of spanning tree for each VLAN. So just because this is the root for VLAN 2 doesn't mean that this would be the root for VLAN 1. Now, if I bring back the I'll bring back the topology here for a second, and you'll notice here that it was switch 3, correct? Yep, it was switch 3 that's the root for VLAN 2. Now, I want to draw out and remind you what the current topology looks like from a trunking standpoint. So we have switch 1, switch 2, switch 3, switch 4. And then I'm only going to draw the trunks that are configured. So we have a trunk to switch 1 to 2. We have a trunk from switch 1 to 4. And we have a switch from 1 to 3. Now, based upon the topology of this network, it wouldn't make any sense, and let me go ahead and put in so this is switch 1, 2, 3, 4. It wouldn't make any sense for switch 3 to be the root, because all the traffic has to go through the root for VLAN 2. And it doesn't make any sense that would mean that all the traffic, regardless of what switch it comes from, has to go to 1 first. So essentially we're creating extra traffic. So if we wanted to go to route 3, or for VLAN 2 traffic, it would go from route 4, or go from switch 4 to 1 down to 3, and then it would come all the way back around to 2. That's not how we want this to work for the spanning tree advertisements. So logically, we would want switch 1 to be the route for all the VLANs. Now, it just so happens for this particular case, let me go back to this, is that we want switch 4 to be the route using the lowest priority. That's actually just part of the lab itself, so from a production standpoint, we would typically not want to do this. We would actually want switch 1 to be the priority, or have the lowest priority. But again, we're just trying to understand how spanning tree works. So again, just trying to show you from a real world standpoint, we would want switch 1 to be the route for all VLANs in this current topology. So with that being said, let's go ahead and contradict myself, and now we're going to go to switch 4, and to make this the lowest priority for VLAN 2 only, the configuration would be spanning tree VLAN 2 priority 0. Now what's going to happen is that spanning tree is going to reconverge. Ports are going to go into listening and to learning, or learning mode first. And eventually, once we show spanning tree for VLAN 2 again, you will notice that now this is the route. Excuse me one second, I have a phone call. So I apologize. Hopefully I'll edit the microphone or the phone ringing sound out. So again, we're back to, we have set switch 4 as the route for VLAN 2. So now we'll go back to our list of requirements. So we wanted switch 4 as the route using the lowest priority, which is 0. Now we want switch 1 to be the backup route, but what is the backup route? What should the value be? So if we go to switch 1, now obviously I'm going to do this command. I'm going to do this command by mistake just to show everybody. But now we want to make this as the backup. So what we want to do is the same command, spanning tree VLAN 2 priority. Now the way that the spanning tree route works is that it's in certain increments. Are the increments 1? No. So if we try to do priority 1, we'll get an error stating that the increments must be in values of 4096. So that means that for the priority for switch 1 needs to be 4096. So now this doesn't necessarily affect spanning tree as far as the route, because all we've done is made this the backup route, so to speak. But to prove that now that when this switch goes down, switch 1 will take over, we will simply just shut down the interfaces going to switch 1. Because if you recall from our topology, if we get rid of, let me get my brush here and use the big red X, if we disable these 2 links, then switch 4 is no longer known to the rest of the topology, therefore switch 1 will become the root. At least that's what we hope will happen. So if we go to the INT range, now we should notice that VLAN 2's root should now be switch 1. And it might take a second here for the spanning tree to catch up. So, and there it goes. So as we notice now, all of the ports are designated. All the status, they're all forwarding or listening. So that is how we've shown that we have configured spanning tree correctly. I'm trying to think of anything else that we need to go over. So there are versions of spanning tree where we can also set a secondary backup. We'll get into that a little bit later, but this is essentially the bare metal version of what spanning tree looks like. So I'm trying to think. I think that it will be it for this lab. On our next lab, we're actually going to go over doing another manipulation of spanning tree, and that is actually changing the costs of the interfaces. So we'll get into that in the next lab. Until then, this is James, and thank you guys for joining.